Hi everyone, in today's lesson we're going to talk about limits at vertical asymptotes. So graphically, when we have a vertical asymptote, we have three possibilities. So the limit from the left and the right is negative infinity. So if you take a look at this example, you see how the left branch and the right branch are both approaching negative infinity. So in this situation, the limit would be negative infinity. Second scenario would be if both branches go up to positive infinity. So then the left and the right limits both approach the same thing. Therefore, the answer would be positive infinity. Or the third scenario is where the limit does not exist, where the right branch and then the left branch approach two different values. This side's going up to infinity, this side is going down to negative infinity, so therefore the limits aren't the same, therefore the whole limit does not exist. So obviously if we had a graph, this would be a lot easier to determine, but you're not going to get the graphs. You're going to get the equation. So an example like this, you have an equation. What we're going to do is just like we've been doing all along, we're going to try direct substitution first. So everywhere I see an x, we're going to put in a -4. So -4 plus 3, and then -4 squared plus 8 times -4 plus 16. So take a minute and pause the video and do the top and bottom separately. So do the top separate, do the bottom separate. Do not put it into the calculator at the same time as one whole fraction. Otherwise, you will get an error message. And then hit resume when you're ready for the answer. Okay, so I got -1/0, which is great because this tells me that there's not a hole in the graph, right? Hole was when we had 0/0. So now we have a number over 0. So that number over 0 means that we have a vertical asymptote. So 0/0 means a hole. So if you want to write that down, we can. So 0/0 means hole. And that's what we did all in the previous lessons. And a number over 0 means vertical asymptote. So that's where we're headed. This is why we always have to do direct substitution first, because if we don't, then we won't be sure if it's a hole or a vertical asymptote. And the way that we handle vertical asymptotes is that we actually have to check a number from the left and the right. So we're going to need a number line as usual. And we're talking about -4. So we know that 0 would be here and smaller numbers like -10 would be here. So we need to pick a number that's really, really close to -4 from the left. So here is the left side of -4. And we want to pick a number that's really, really close to it. So that number could be like -4.1, right? That would be a good answer. So now what we're going to do is we're going to plug into the top and the bottom. We're going to plug in -4.1. So we're going to do -4.1 for x plus 3 over -4.1 squared plus 8 times 4.1 and then plus 16. So same thing, we're going to use the calculator. Go ahead, type the top in, type the bottom in, and get me two separate answers, and then hit resume when you're ready. Okay, so for the top I got -1.1, and for the bottom I got 65.61. Now, it doesn't matter what these actual values are because all that I'm looking for is that if my answer is positive or negative. So when I divide a negative by a positive, my result will be positive. So I can just say that I have a negative divided by a positive, and that answer is positive. So therefore, we can, let's go back. A negative divided by a positive is a negative, therefore my answer will be negative infinity. So it doesn't actually matter what the number is, it just matters what the sign is at the end. And let's go ahead and confirm that. So we're going in from the left. So here's the left side of the graph, and yep, we're approaching negative infinity. That proves it, okay? So now we have to check a value from the right. So if we go back up to our number line that we drew before, here's the right side of -4. So something to the right would be like maybe -3.9. So let's try that and plug into the original equation. So the original equation's all the way up here. So everywhere we see an x up here, we're going to put in our -3.9. So -3.9 plus 3 over -3.9 squared plus 8 times 3.9 plus 16. So again, pause the video, type the top in, type the bottom in, get me two answers, and then hit resume when you're ready for the answer. Okay, so for the top, I got negative 0.9. And for the bottom, I got a positive 62.41. Again, it doesn't matter what number this is and what number this is. It matters the sign. So the negative 0.9 is negative. The denominator, 62, is positive. So a negative divided by a positive is also a negative. Therefore, we can say negative infinity. So this proves that the limit from the left is negative infinity. The limit from the right is negative infinity. Therefore, the limit as a whole is negative infinity. So the left and the right are equal, therefore the whole limit is also equal to that negative infinity. And this graph proves it, right? This graph proves that they both go to negative infinity, so that would be our limit. Okay, let's try the second possibility. So the second possibility is a limit to positive infinity. So again, we're always going to try direct substitution first. So I'm asking this as x approaches 3. So let's go ahead and directly substitute 3 and see what happens. So 3 plus 1 over 3 squared minus 6 times 3 plus 9. So take a minute, pause the video, and get me two numbers. Okay, so we should have gotten 4 over 0. So again, same thing that we wanted from before. We got a number over 0. That means that there is a vertical asymptote. So we have to check values from the left and from the right. This time I'm asking from 3. So I'm just going to draw myself a nice little number line again. So here's 3. We know that this could be like 5 or 7. Oh, wrong way, sorry. We know that this could be 0 and that this could be like 5 or 7, right? So a number from the left side is coming in from here. So something really, really, really close. So maybe 2.9. All right, so everywhere we see a x, we're going to put in a 2.9. So again, 2.9 plus 1 over 2.9 squared minus 6 times 2.9 plus 9. So I'm going to say to pause the video, plug these into your calculator, but you don't need to get me the numbers. All I care about is this positive or negative and what they divide out to. So take a minute, pause the video, do that, and then hit resume for the answer. Okay, so they actually both came out to be positive. So a positive divided by a positive is positive infinity. Now we're going to check the right side yet again. The right side, we're going to plug in a number that is really, really close to 3, but from the right side. So from here, this is my right side of the graph, so maybe something like here, so 3.1. So we're going to plug in everywhere I see an x in here, but we're going to plug in 3.1. So 3.1 plus 1 over 3.1 squared minus 6 times 3.1 plus 9. All right, take a minute, pause the video, type those in, and then hit resume when you're ready for the answer. Okay, so they both come out to positive again. So a positive divided by a positive is simply positive infinity. Now, if the limit from the left and the limit from the right are equal, that says the limit as a whole is the same thing. That limit is also positive infinity. So we've got here and a proof on my graph. The limit from the left goes up to infinity, the limit from the right goes to infinity, therefore the whole limit goes to infinity. Okay, let's talk about the last one. The last one, the limit does not exist, which is clear from the picture. Let's prove it algebraically. Again, you're not going to always have the picture. So let's try direct substitution first. Let's go ahead and plug in -1. So -1 squared, 3 times -1 minus 28 over -1 squared minus 6 times -1 minus 7. So again, pause the video, get me two numbers, and then hit resume when you're ready. Okay, so I got -24 over 0, which perfectly fits what we need it to, right? We need a number over 0, so a number over 0 means vertical asymptote. So let's prove this now algebraically. We need to pick a number from the left of -1 and from the right of -1. So again, a number line would be helpful. So here is -1, and we can say that 0 would be here, and we could say that -2 would be here. So a value from the left would be coming in this way. So here would be like -1.1 would be good enough. So everywhere I see an x, we're going to put in -1.1. So here as well. So -1.1 squared minus 3 times -1.1 minus 28 all over -1.1 squared minus 6 times negative 1.1 minus 7. So again, pause the video, type your values in, and hit resume when you're ready for the answer. Okay, so my numerator was negative, my denominator was positive, therefore a negative divided by a positive is negative. So the left side goes to negative infinity. So now we're going to do the same thing from the right. So let's go ahead, here's my right side. I'm going to try maybe negative 0.9, which is really close from the right. So again, negative 0.9 squared minus 3 times negative 0.9 minus 28, all over negative 0.9 squared minus 6 times negative 0.9, and then minus 7. So again, type those values in, hit resume, hit pause, and then resume when you're ready for the answers. Okay, so I got a negative on top and a negative on bottom, which means a negative divided by a negative is a positive. Therefore, my answer would be positive infinity. So what we can see here, when I'm asking to find this limit, the limit from the left and the limit from the right are not equal. Therefore, my limit is DNE. So these are the 3 and only 3 scenarios that you're going to get. Your limit is either going to be negative infinity, positive infinity, or does not exist. The problem is that you have to do all of this work just to do it. You have to check your left and your right to see your limit. Okay, so on the back, there's a couple of practice problems. So what I would love for you to do is take a look at these two. Notice that this one's only asking you the right limit, and this one is asking you both. So we'll try these for homework, and then we'll start class by going over these tomorrow. All right, have a good night.